Next, moving on.
Well, this one is 11.
I'm gonna.
This is 10.
Okay. Last test. Here it comes. It's called the alternating series test. Now, this has a visual clue. You're going to use the alternating series test when your series alternates, which means change of sign. So clue number 1, alternating series test, your series alternates. What do you look for to know it's the root test? Not something to the power of n. All the things. All the things are being raised to the power of n. All the things. Because you're going to have to take the nth root of all the things. What's the visual clue for ratio test?
There's a factorial or...
Seeing a factorial is a good clue ratio test. Another thing is when you have powers, exponents. Okay? But if it's powers of n and that's all powers of n, I would probably go with the root test. Okay? Ratio test, what we're looking for is that the signs are alternating. Now the signs could be alternating in either, like if I were to write out the first term here, if n's equal to 1, I'm going to get a negative exponent. So this is a series where it goes negative, positive, negative, positive. If you go over here, if n's equal to 1, now you get negative 1 squared. This guy's going positive, negative, negative. Both count for alternating, okay? The alternating series test, there are 3 things that you're going to look for. Number 1, it alternates. Check. Number 2, if the limit as n approaches infinity of the a sub n's is equal to 0. This should make you think of another test. The nth term test. But on the nth term test, if you said limit as n approaches infinity of a sub n and you get 0, the test was inconclusive. Here in the world of the alternating series test, if your series goes minus plus minus plus or plus minus plus minus, you need the nth term to approach 0 and you need the sequence to be decreasing. If you have all 3, then your series will converge by the alternating series test. So these are the 3 conditions. What are the 3?
Alternating.
Has to alternate.
Limit to infinity.
Limit as n approaches infinity has to be equal to 0. And the last thing?
A of n is decreasing sequence.
The sequence has to be decreasing. These are the 3 conditions, and if you have them, then you get to proudly say, great, I have convergence. All right, so now here's the thing. You will never, ever, ever, ever prove divergence of an alternating series.
Yeah, we know.
Not with the alternating series test. You will never do that with the alternating series test. The alternating series test has one outcome, and that outcome is convergence. I guess the other outcome is don't know. Go for another test. Okay? Big picture, all right? All right, so let's just roll up the sleeves and get to work. All right, so let's look at this first one. Oh. Does your handout go from 1 to page 4?
Yeah.
Yep.
Okie dokie. My mom is not actually nearly as good at making copies as she thinks she is. She's never actually made the copies correctly for me on the days that I have to be somewhere else. My apologies for that, friends. So get a separate sheet of paper. Never, ever,
We're doing
never
college
has
notes
she
here?
actually gotten the copies right.
Wait.
It would upset her greatly.
Are you
But man, is it
You
true.
play football, you don't have to go to class.
are you posting this
You play
video
football, you
online?
don't have to go to classes.
Oh God, now someone's gonna blackmail me because there's gonna be this like video out there like my mom didn't know how to make copies.
That'd be the next video.
Nathan's just like...
Oh, all right.
That'd be Nathan.
Apologies. Here we go. Problem number 1. The series goes from n equals 1 to infinity. Negative 1 to the n plus 1 times n over 2n minus 1. So let's run down the list here. Does the series do all the things?
I would
probably alternate.
Okay, alternating, is that okay?
Yeah.
Okay, alternating. ALT is fine.
Limit to infinity does equal 0.
It does?
Control.
Now, here's the thing, if you look at their definition for alternating series, this guy here is what they call the a sub n. This -1 to the n, the -1 to the n plus 1, that's the alternating part. Their series is just the positive terms. Well, limit is n approaches infinity, yes, that's infinity, of n over 2n minus 1. What is that? That's a half,
Oh.
Oh yeah.
which is not equal to 0.
Oh.
So
Nope, we can use it.
wouldn't it diverge by the nth term test
Okay.
instead?
This series, although it does alternate, doesn't count. You cannot use the alternating series test because
Limit to infinity does not equal 0.
the limit to the infinity is not equal to 0. So I would make a little statement here that says like AST does not apply. Okay, I cannot prove divergence with the alternating series test, but here's the little clue for us. Right? If I just took the limit as n approaches infinity and I get something that's not equal to 0, what are we going to say? Therefore, this series here, n goes from 1 to infinity, -1 to the n plus 1 times n over 2n minus 1. This guy over here diverges by, to get the test right, by the nth term test. You have to check all the conditions. I need to see alternating. Had I gotten 0 as an answer here, I still wouldn't be done. You'd have to check, is the series decreasing? You have to hit all 3. Pretty good? All right, let's try the second one. All right, and the next series. Good. Where'd my solutions go?
Then we have to come up with a of n plus 1 after that?
Hold on one second. I just had my solutions. They're over here.
I think they're in a red folder.
They're in a red folder. Now they're over here. They're over here. I've got to go to the solutions that I worked through this morning. All right, try this one. Goes from 1 to infinity, -1 to the n over n.
No, can we say that? Can we say that a sub n is 1 over n?
Yeah.
So Harman? Yes.
Okay, so let's run through 3 things that we're looking for.
Alternating.
Does it alternate?
Yeah.
Pretty obviously, right? Okay, Brian, what's the next thing you're looking for?
Limit or?
Right, I mean, you don't have to do it in this order, but now let's be careful. We're taking the limit as n approaches infinity of the a sub n. What's the a sub n in this case?
1 over n.
The a sub n is 1 over n. So I take the limit as n approaches limit as n approaches infinity, 1 over n, we get 0. That's a good thing. That's not an answer. Not an answer.
Okay.
The last thing?
Decreasing.
Does this sequence decrease?
Yes.
Yes.
Decreasing, the terms get smaller in value.
Yes.
Oh, value.
As the n increases, does 1 over n decrease?
Yes.
Sure, that's one way to do it. So you could say as n increases, 1 over n decreases, right? You could make a verbal statement that way. Other thing you could do, you could say, let me look at f of x equals 1 over x, and if I take that derivative, I'm going to get -1 over x squared, and that's less than 0 for x greater than 0. So you can make a verbal argument,
Oh, I got it.
or make a
Yeah.
calculus-based argument.
This is decreasing with the negative.
Okay?
Could you explain this portion that is a of n plus 1?
Oh, so it's like, let's say a of n was 1, right? So then it would say 1 plus 1, which is a of 2, right? So it would say a of 2 is less than a of 1.
I like what you're saying, and you're asking the just right question. But you have to be able to compare these in general, not for a specific number. You need the relationship to be true always, that 1 over n plus 1 is less than 1 over n. Is that always true?
Yes.
So is that like a hidden third condition that we need to find?
No, it's not it's not a hidden third condition, it's another way to say decreases.
Oh, okay.
Right? Because what we're saying here is that a sub n plus 1, the next term, is always less than the term I was just at. So show it this way through like a verbal, use a little calculus argument, or argue through inequalities. I would probably start though with the relationship that n plus 1 is greater than n, and then when I take the reciprocal, 1 over n plus 1 has to be less than 1 over n. Decreases. So let's hit all the things. We've got alternating, approaching 0, decreasing. Conclusion? Therefore, the series. I need to see the series. -1 to the n over n. What do we say? Converges? And why does it converge? Converges by the alternating series test. Okay. All the friends okay? All right, now it's time for a bubble burn. All right, have some fun with this one. Here comes the series. Don't pick on his mom. His mom's
You
a
already used all the
wonderful
bags.
lady.
There's people over there. I know.
Good luck, friends.
What did you do? Wow, it was
Oh.
Good luck.
I'm not criticizing me for my.
Maybe?
Then, those two.
Oh. You went with me.
Criticizing me for taking up new term space. I don't see you complaining about this.
No,
Because I'm saving paper.
Yeah.
Shut up.
Isn't it?
Oh yes, we're gonna love this game.
Oh, I know.
Why do I have to put the -1 parentheses?
Why do you have to put the -1 in parentheses? You're asking like, why can't I just do that?
Yeah.
If you do that, what's being raised to the power of n?
The one.
Just the 1. Not the negative. It'll never alternate.
Pretty sure you would have made the same mistake.
Here you go.
Totally agree, yeah.
Because the slower ones are the top. Doesn't it? Because it turns out to be infinity and infinity. It's 2 infinity. The natural outward infinity is infinity.
Did you get that book? That's what I
Alright, so does this one do all the things? Or not?
The limit is not equal to
Okay, the limit's not equal to 0. How do you know the limit's not equal to 0?
And the same thing happens.
Right, so the top grows faster than the bottom, so the limit is infinity. All we really care about now is 0. So what's the conclusion?
AST doesn't apply.
The AST doesn't apply, and now you get something for free. Right, it doesn't, the AST doesn't apply, but you get divergence by the nth term test.
It just ends up being infinity.
Alright, friends over on the side.
I mean, very order.
Okay.
For the original, right?
Yeah.
This one is gonna mess with your head.
No pixel zero.
N goes from 1 to infinity.
Okay.
What is going on there? N -2 to the n plus 1. Go for it. Okay, friends over here. Alternating, we got it?
Yes.
Okay. The a sub n is n divided by the natural log of 2n. If I take that limit as n approaches infinity,
What?
of n over the natural log of 2n, you get infinity over infinity, which is bad. You could use L'Hopital's rule, or relative growth rates, natural log, slowest growing function out there. And so that limit is infinity. Conclusion, this series over here diverges. Right, diverges never by the AST, diverges by the Nth Term Test. All right, when are you guys trying number 4? Let's see how that handout is.
I mean, I bet that it does alternate.
I'm about to say, Lucio, what's wrong with you? You can't kill all the trees.
So yeah, it does also.
You can only think good thoughts about it. What'd you say?
At least you have it.
Wait, what's the?
You guys did it alternate?
Yeah.
Are you sure it's just n?
Really? Because the negative two.
But then there's at the bottom.
Alright, so
Yeah.
I just don't know what the A is.
Just become one.
He doesn't know.
Yeah.
Now you take the one, we take the limit, which is easy. It is alternating thing, right?
He just said the answer, but you just said, I don't know.
No, like,
You can do the negative,
Would it just be in?
because that becomes negative. No,
Yeah, just feel like if you don't mind,
one over most of the power then.
Hours.
So,
it's gonna look
everything will be
like
foldable, and then
So I take this. So you want the whole thing copied now?
isn't it?
No, I've
negative
already-
n minus 1?
just that one page.
That's what I'm
So I
doing.
just printed
Catch up
45
on-
copies of that one page.
Oh, so I'm just beginning.
And I printed it, just the one outside of your office.
Yeah.
Okay, so one test. Okay.
Thank you so much. All right, does this series do the things?
It does alternate.
Alternative, yes.
it alternates.
It alternates. Okay, we're not going to be worried. It's -2 to a power,
Yeah.
right? If you need to split it apart, and this is really what n, and then -1 to the n, to n plus 1. Sorry, times 2 to the n plus 1. I'm alternating. Whether that -1 to a power shows up in the denominator or the numerator, I'm still alternating. That's all that matters. All right, and the a sub n is equal to n divided by 2 to the n plus 1. Okay, we've got alternating. Next thing?
I'll find the limits.
Okay, let's find that limit. Usually, the limit is a good one to find next because that'll be able to tell you pretty quickly, should I move further or not. And what do we get here?
0.
What is that limit?
Yeah.
Why?
To anything power is 0.
Okay, wait, 2 to the infinity power is 0? 2 to the infinity power is infinity. In the numerator, infinity as well. We're getting infinity over infinity.
The hospital?
So if you want to use L'Hopital, feel free to use L'Hopital. You could do that. Or have a rate conversation here. The fact that it's 2 to a power, the important thing is that it's an exponential.
And it's large.
And exponentials grow faster than any other thing on the planet. So n over 2 to the n plus 1 is going to be 0. Great. I've got that thing. Last thing? Decreasing. This is going to be the tougher part. you would have to convince me that you know that this series decreases.
So could we use the values?
So maybe you want to make a table of values and try that for a little while. But that won't show me that it decreases forever. That'll only show me it decreases until you stop. So another way to show decreasing is, let's look at the function version instead. Let's look at f of x equals 2x over 2 to the x plus 1. And I want to check decreasing. So what am I going to do? Take a derivative. Okay. Got to take the derivative. X over 2 to the x plus 1. Quotient rule, right? So low, 2 to the x plus 1, d high, 1, minus high, here it comes. Derivative of 2 to the x plus 1. So we did this one once.
With a.
Right. When you take the derivative of something like a to a power, it's a to the same power, just like the natural log, times the natural log of a. So in this case, the derivative of 2 to the x plus 1 is going to be 2 to the x plus 1 times the natural log of 2, all over 2 to the x plus 1 squared. So all you need to be able to do is show me that that's always negative.
So 2 to the x plus 1, if you want to make it easier for you, you separate it into 2 to the power of x plus 1 times 2 to the power of x plus 1. And
Oh, you
then-
mean down here?
Well, yeah, that's my
Yeah.
my thought process, right? And then you would cancel out, right? Because 2 to the x plus 1 times 1 is the same number.
2 to the x plus 1 times 1 is 2 to the x plus
So
1.
you would cancel
Yeah,
one
you
amount,
should
you would end
factor
up
it
with a
out.
No,
negative.
you can't. You can't. Even if you guys convince each other, you can't.
So we can't factor.
You cannot cancel this guy here with this guy down here because of that subtraction sign.
Just
You
like that.
You
can
can
only
factor it.
cancel factors.
Okay, so if you factor it out, you can
There's the thing. So you factor out the 2 to the x plus 1, and what are you left with?
1 minus x.
1 minus x times the natural log of 2
That's what she meant.
over, oh, so nice. Way to back her up. 2 to the x plus 1 times stuff over 2 to the x plus 1 squared. Thanks, Mr. Lane. So that guy and one of those cancels out. Now I've got to decide about the numerator. 1 minus x times the natural log of 2.
I just think it's a bigger number than
You think, I think it's bigger, so that's probably it.
Well, it's a negative for any.
Wait, didn't you say if we natural log is the slowest growth
Only
function?
negative?
Natural log grows slower than anything else.
And yeah,
But-
exponential.
Here, but we're looking at the derivative.
I mean, as long as x is greater than 0, then it's going to be negative.
Not true.
It's not?
Nope. The natural log of 2 is 0.693.
Oh. So some x is some number and it's going to be greater.
Okay, but what you said is that as long as x is positive, this whole numerator is going to be negative. Not true.
Oh, wait.
This is about 0.693.
Shouldn't it be
That
greater
is gonna be
than
negative.
1 over natural log of 2?
Which should be greater than 1 over the natural.
X should
So, but x, if we're looking at series, these have to be whole number values,
be greater
right?
than 1.
So as long as this value of x is greater than 1, right? Like 2 times 0.693, who cares, right? It doesn't, all I care about is how does that compare to 1. So I'm going to say that this guy here is negative for x values greater than 1. So getting there, look at what I've got. I've got alternating. I've got nth term approaches 0. I have decreasing conclusion.
AST.
Therefore, not even just that the AST applies, this series
Convergence.
n over negative 2 to the n plus 1 converges by the AST. Everybody mostly doing okay? All right, so now I think we actually return to the world of there's a complete handout. So we've got convergence and we've got divergence. We've got all the different series tests. Life is good. There's Caroline's work. Put it back in the recycling bin.
Let's see.
Focus. Focus. I've got one more idea to introduce you guys to. And that is that there's more out there than just divergence and convergence.
Absolute convergent.
There's something called conditionally convergent.
What's that?
Well, I'll tell you. So here's like my little word web here. In the land of series, there's two kinds. We have the divergent series, and I don't mean the one by Roth, whatever her name is. And we have convergent series. So divergent heads off to infinity. Convergent series gets closer to a number, right? In the world of convergence, there's two flavors. There's absolute, well done, Roger. There's absolute convergence and conditional convergence. And this is what it means for a series to absolutely converge. If you look at the series of the a sub n's and you take their absolute value, if the absolute value of the series converges, then you have absolute convergence. Conditional convergence is when this original series converges, but the absolute value diverges. Okay. So that's sort of the breakdown of what series can do. Divergence versus convergence. And then in the world of convergence, we're going to look at absolute convergence and conditional convergence, which gets us closer to Taylor series approximations, which gets us closer to figuring out radius of convergence and intervals of convergence for polynomials and all the fun things. Don't worry, guys, the easy stuff's almost over. Okay. We'll get there. We'll get there. Right now, we're at the point I just need to be able to say the things right again and again and again. All right, so let's look at a couple of series. I think what you guys are going to find is that these are fast and fast and furious, all at the same time. Here's what these questions are going to look like. There are no questions like this on the quiz that you are doing tonight that's due Thursday morning. Okay? Yes, later on, yes, the next quiz will look like this. You're going to be given a series and you're going to be asked not just one question now, but two questions. You're going to be asked, does the series converge or diverge? If the series diverges, good news, done. But if you converge, now you're going to ask, is there a stronger convergence? Is there absolute convergence or conditional convergence? What? Welcome to Calculus BC. All right, so first of all, I want you to decide, does the series in and out as it is presented right now converge or diverge? Go get that one for me. Number one. Does it converge or diverge? If it converges, why does it converge? right, hopefully you guys are done with the initial series test. This would converge by the alternating series test. Clearly, we've got alternating. Okay. Limit as n approaches infinity is 0. And I just chose to write out my decreases argument. As n increases, the square root of n increases, so the reciprocal decrease is done. So the series converges by the alternating series test. Now you ask that second level of question. Absolute or conditional? There's just one more step. So the next step is, right now it's a matter of like looking at absolute convergence. So look at the new series. What's that new series if you take the absolute value of -1 to the n over the square root of n? Don't overthink it. The absolute value of -1 to the n. What does that absolute value do? Is one thing.
Doesn't it just change up the sign?
Right? It just changes the sign. If you had negatives, you now have positives. If you had positives, you still have positives. So the absolute value of -1 to the n over the square root of n
Does it just be one apart?
is just 1 over the square root of n. What does that series do?
Divergent.
Divergent.
Wait, what?
Didn't we just say convergence?
Hold on.
That's what the alternate.
Oh, okay.
If we're looking at the alternating version where you have these plus minus, that converges, but now we're asking about a different series. We're looking at the series if all the terms are positive. What does that series do? And why?
By the P-series test.
This is a P-series test.
So just need
So it's a P-series. P is equal to a half, which is less than 1, so the conclusion for this series diverges. So what would we say about the original series?
conditional.
Right, we know that the original series converged by the alternating series test, but when I take the absolute value, I get divergence. The conclusion is going to be, therefore, this series, n goes from 1 to infinity, -1 to the n, over the square root of n, conditionally converges.
By, do I have to put by?
Great question. As far as I know, based on the reading I've done, no. Because you've already used a test and said what test you're using over here, right, with the original series, and then you used another test over here. Getting to conditional or absolute value, absolute convergence, you're normally going to have a combination that we're doing here. But first, ask the question, converge or diverge? And if it diverges, stop. Okay. All right, so let's see. Do you guys want to feel good about yourself or bad about yourself?
Good.
Okay, feel good about yourself, try number 4.
What about that?
Try number 2. All right. Choose your poison.
Number 4?
I don't know.
Take the cosine. I'm out. I'm out. You just rewrite it.
Is it too late to go back to AB? Lucio.
Wait, isn't that just like negative?
Yes, you're right. Yes. That cosine of n pi, you only have 2 possible answers.
Negative 1 and 1.
You get -1 or you get +1. So that's another way to show alternating. All right, we'll give you guys a little bit of time here.
Yeah, you're fine.
So 0.
Oh, yeah. Yeah, you guys might not like this one.
So how can we cancel the natural unconditional? Wait, that doesn't work.
Oh yeah.
What do you say, baby?
But you quite that didn't work.
No, I think not.
Okay.
So.
Oh no, it doesn't even increasing.
It does?
Let's say just give me 0.
I'm out of
What do you say? How do you say it's increases?
This is 0.
That's what I said.
So it converges like this.
Oh, okay.
Whoa. Hey, does this converge? I mean, does this alternate?
Let's go in here.
Oh, it is the moon spin.
Alright, hopefully alternating was obvious.
Yeah.
Taking the limit as n approaches infinity, getting to 0, hopefully also obvious. Okay? Curious, did anybody go with this verbal argument?
I was gonna do it.
Okay, you went with the verbal argument?
I just can't
Okay. Right, really, I'm just writing down what's happening in my head. N gets big, n plus 1 gets big, natural log gets big, 1 over that gets small, all the things. Converges, not done. Now we need to look at the absolute or conditional convergence. Okay, so if we're going to test for absolute convergence, now you're going to take the sum of this series, absolute value, -1 to the n, natural log of n plus 1. You know that those absolute value bars just eat the alternating term. And now we need to pray.
Oh my god.
What are the options?
Can't remember.
Okay, you could try the nth term. What happens?
Because it's equal
I
to.
know, but he said what are
Right.
the
What are the options?
Oh.
Start easy. Start with the nth term.
But it
Inconclusive.
doesn't.
Inconclusive. Good. Next.
Geometric.
Geometric. No.
No.
Telescope?
I don't even have C subtraction. Not telescope.
Not P series.
That don't happen.
Not a P series. Not gonna happen.
Answer.
The fact that all these thoughts are even in your head in a week and a half is pretty incredible.
Limit comparison test?
Maybe you want to do a limit comparison test. If you're going to do a limit comparison test, what do you compare it to?
Natural log.
Over natural.
1 over natural.
1 over natural log.
1 over the natural log. But here's the thing. If you're going to do the limit comparison test or any comparison test, you have to know about the series you're comparing to.
No.
The comparison tests are great when it comes to P series because we understand how all the P series behave. Natural log of n, not a P series.
Integral.
Okay, integral. That means you're going to have to integrate 1 over the natural log of x plus 1.
1 squared.
That could be a problem. Right? I mean, but these are all the ideas that you want to go through. These are all the ideas I want you guys to be going through right now. Well, this part was. So here's what we're going to do. We're going to compare. Compare to 1 over n.
Why 1 over n?
Because it's
Why 1 over n? Well, what does this guy do?
How come we always use 1 over n?
Because it's a friendly
It's a
function.
harmonic
It's a
series.
friendly-
So
It's harmonic,
Diverge.
so
diverges.
diverges. Okay. Now, if you can, let's see, if I want to show divergence, if I want to use direct comparison, then you have to be able to show me that this is a smaller series than this guy over here. If you want to use limit comparison test, all I need to know is that all these terms are always positive, and that all these terms are always positive. Okay? So that would be the choice that we'll continue talking about Thursday. There is nothing on the quiz involving absolute or conditional convergence. But alternating series test is on there. It has to be on there.
Is there any more tests?
Not that we are going to cover in the world of Calculus BC. Well, yes. Yes, thank you for interpreting what I said correctly.
when are we getting to the real world application?
When we are going to start that next week. Brian.
This is the absolutely convergent and conditionally convergent only apply to AST or
If your series isn't alternating, if all the terms are positive,
yeah.
then there's no difference between your original series and taking the absolute value of the series.
Alright.
great.